Week two, how was week one for you? Hope you got a good sense of the key ideas that came out from week one. We're going to be using some of those ideas here in week two, and actually we're going to be using one of them, some of the work we did with indices and substitution. That comes up now. So let's see the situation for question number one. How did he fare with this one? First, we've been asked to identify two errors, so we're going to find two problems. And the first problem you should have identified is that plus sign. Yeah, that's not supposed to be there. Because remember, for multiplication, we add the power. So if I have 2 to the power 2x multiplied by 2 to the power 4, it is that. If I have that expression, the multiplication, not the add, that is equal to 2 to the power 2x plus 4. So that was the first issue here. It should have been multiplication, and you want to make that clear that that plus sign should be a multiplication sign. The second problem occurs down here. Add 8. 8. Where did the 8 come from? If we follow this person's work, 2 to the power 4, they're adding 2 to the power 4 and 2 to the, so this is the first one there. The second issue is 2 to the power 4 is equal to, that's right, 2 to the power 4 is equal to 16, not 8. So that's your second issue that it should that should be there. So not plus. So you would have written not plus, multiplication, not plus, and for the first one, just to be clear. So those are the two errors identified there. Now we know what's supposed to be there. Let's actually do the problem. So, well, let me make some space here, and I'll write the problem out and get started with it. Yeah, it's always tricky for me to do this. Make sure I have space. Or did I have a second? Yeah, I've got a blank page, so I'll work on a blank page. Okay, so the second part B, the exact value. So let's get on with this. The first thing I'm going to write, my first line will be the substitution. So we're keeping this, we're just switching to multiplication. So we'll write is equal to 2 to the power 2x, multiplied by 2 to the power 4, take away 9, multiplied by 2 to the power x, and that's equal to 0. So that's what we're looking at there. And then, well, I can actually write this as that 2 to the power 4, I'm multiplying it by it, and 2 to the power 4 is 16. So I can write that this is actually 16 being multiplied by 2 to the power 2x, take away 9, 2 to the power x, and that's equal to 0. Now, we're going to keep this idea. Yeah, we're going to keep that idea of letting y, let 2 to the power x, so I would say y is equal, I'll say let y be equal to 2 to the power of x. And then this, we can do a substitution for y, and the 2 to the power 2x, that's where the change comes in. Recall that 2 to the power 2x is actually the same thing as 2 to the power x squared. In other words, it's actually the same thing as y squared. And that we looked at that idea in last week's session. I think that came up once or twice in substitution work for indices. So hopefully we're okay with that. And from that, we can write our next line. What do we have? We actually have 16y squared, because the 2 to the power 2x is actually y squared. So 16y squared, take away 9y is equal to 0. Now, where do we go from there? Is that enough for you to get going if you were stuck? And remember the power of the pause, you can get going. Okay. I'll factorize. This is what I would do. And the common factor is y. So y comes out, and I get 16y take away 9 is equal to 0. So that's what we have there. Factorizing is what I would do next. Is that what you did? Is that what you're thinking about? Remember, power of the pause, you can take charge at any point you want. Once we have the double brackets is equal to 0, what does that actually mean? It either means that y is 0, because to get 0, one of the numbers I'm multiplying by has to be 0. So y equals 0, or what value would make the bracket 0 in here? It's going to be y would have to be, y is going to have to be 9 on 16, okay, which is equal to 3/4. I can write that quickly, you know. That's the only answer that will work here. And to be honest, you know what? I'm not going to encourage this. There's no need to simplify it, so let's not simplify it. Okay, so 9 on 16, because 9 on 16 multiplied by 16 would give me 9. 9 take away 9 would give me 0. So those are the two solutions for y. So far, so good. Are we good? Now for a big learning point. Something you didn't have to deal with in GCSE at all is going to come up here. Because you need to remember, and we looked at this last week, We're not done. To solve the equation, solving the equation is finding the value of x, not the value of y. So now we need to use our substitution. And let's see, y is equal to 2 to the power x. So when y equals 0, we're suggesting 2 to the power x is equal to 0. So 2 to some power is 0. What power do you raise 2 to get 0? Yeah, that's right. No power. It's not possible. Not possible. So we'll just write no solution. Yeah, there is no solution. Because remember, if x is 0, 2 to the power 0 is 1. Any number to the power 0 is 1. There is no power that can give you 0. Yeah, there is no power that can give you 0. No power of 2 can give you 0. Let me be clear. 0 to a power can give you 0, but there's no power of 2 that will give you 0. Okay, so there's no solution for y being 0. We can ignore that, but I gotta be careful. You can't just say you ignore it. You will state that there's no solution. Make it clear you're doing a substitution. And now let's deal with the second situation. When y equals 9 on 16, we have to think now some number 2 to some power is going to give me 9 on 16. So 2 to some power is going to give me 9 on 16. How do I work out that power? This is not the work we did last week. You could have figured out what the power was, a -2 or a third or something like that. But 2 to what power will give me 9 on 16? Not going to happen. And note, they also, when I say something, you can't figure it out because it's going to be some decimal figure or something like that. And that's why the question said find an exact solution. They even gave you a hint here. They said solution. So if you were thinking there's solutions, you should realize that's not true. There's only one solution to this problem. And that's in the hint there with the language. That was in the language. And they said exact. When they use exact, you got to start thinking maybe the answer might be a surd. That's reasonable. That's an exact value. But in this case, it's not. It's not. That's not what we're looking for. Welcome to the world of logarithms. The opposite of a power. So what is a log? You've seen the log button on your calculator. The answer to this is x is going to be log, and I'll put a little 2. That means the logarithm. Log is short for logarithm, and the little 2 or the subscript 2 means that we're working in base 2. Remember the big number, you've decided a big number is the base. And then I just need to write the fraction 9 on 16. And just for clarity, I'll write it a bit bigger here. This is the only answer to the question. Let me just put it over here because I'm ending up. I feel uncomfortable. I'm getting in the bottom left corner. Right corner, sorry, get in the bottom right corner. So I'll write it again. We have y, what do we have? We have y is equal to 2 to the power x, which is equal to 9 on 16. That means that x is log 2 9 on 16. That's our answer. That's our exact answer. And what does that mean? I mentioned a bit earlier, a log is the opposite of, or the inverse of, a power. Log 2 9 on 16 is saying the logarithm is the idea you got to think about. The logarithm is a power. So log 2 9 on 16 is the power you would raise the base, the 2 to get 9 on 16. Hopefully that makes some sense. So when you're finding a log, you're finding the power you'll raise the base to, the subscript number 2, to get the value that comes after the subscript. That's what that means. And to really bring home the idea, let me just make some more space here, and I can make more space, but I'll push down a little bit. Yeah, that's a lot better there. Examples of logarithms and what this log and why that is our answer. That's your exact value. That gives you your tick. If I put log 10 100, if you were to work that out, what that is, that's 2. Because log 10 100 is saying what power do I raise the base 10 to? 10 to what power will give me 100. That's what the logarithms find. So if I do log 2 16, the answer to that would be exactly, it'll be 4. Okay, so the log finds the power. It's the opposite of working out the power. It's actually finding what the power or the index or the exponent is. That's what a logarithm does. It's saying, when I write this, I'm saying what power, log 2 16 is saying, well, what power of 2 will give me 16? That's what it's saying. Okay, so, and that's what we want. If 2 to the power x is 9 on 16, x is the power of 2, that gives me 9 on 16, which is what the log works out. And they said to give the exact value, so we'll just leave the answer as log 2, 9 on 16. Okay, so welcome to the world of logs. When you want to find powers, you do log, subscript the base, and the value you're trying to find, what power to raise to. So if I did, last one I'll just write down for example, if I did log 5 125, what would the value be? Brilliant, you get it. It's going to be 3, okay? Because 5 to the power of 3 is 125. So to find powers, you use logarithms. New idea. It didn't come up in GCSE, but here it is. You'll be using that a lot in A-level. Okay, right. So let's move on. Number 2, and I probably should have put number 2 first. Yeah, that would have been a nicer introduction. Hopefully you had no issues here. We're working anti-clockwise. So I want the cube root, so root and then power. Yeah, root, the 3 is the root and 4 is the power. So we want the cube root of 8, and whatever that is, we're going to raise it to the power of 4. And that is indeed a 2. So 2 to the power of 4, which will give us 16. For the second one, maybe a bit more challenge. We'll separate it. We got 15 on 3 being multiplied by x to the power 4 on 3 on x. So I've separated it. That's the way I prefer working with it. Hopefully you're okay with that. Working 15 on 3, that will give you 5. And then x, recall, this is the denominator is x to the power 1. And for division, fraction bar means to divide. For division, we subtract the powers. So I got 4 on 3, take away 1, which would be a third. So it's 5x to the power a third, and that will be your final answer. That's your simplification. So hopefully no issues with this. Your negative indices, fractional indices, you want to be comfortable with that at A-level. Right, the curve sketching. This was a nice one. Hopefully you were okay with it. If not, it's flagging up this idea. You gotta be good with your curve sketching. So recap that. You can Google it, etc. Or use YouTube. You'll find other videos on it. I'm not focusing in detail on one topic, but generating awareness and hopefully at sufficient detail for it to be okay for you. The first one, y equals f of x plus 3. The plus 3 is outside of the bracket. That tells you that the change is happening on the y-axis. So change the y values. That's what it's saying on the inside, on the outside. And when you change the y values, it's a direct relationship. So what this is telling me is take the y value, because f of x represents the y value, and what this is telling me is take that y value and add 3 to it. So in your sketch, and it is a sketch, it doesn't have to be perfect. I mean, use a ruler to get those. It's easier for you to handle that on paper, even for me to deal with it on paper. And what do we want? What am I saying? That's 7. You have to show the points. So the shape of the graph and the points, that's what we're interested in. We want that shape and the points. Here, moving up 3, I would get now to the point 0, 10. So that will, you could just put 10, or I'll put 0, 10 is the point there. And then this point, this is going to go up to 7, 3. We're just changing the y values. So this is going to be 7, 3. 7, 3, and you would do your curve similar to what they have there. Obviously, yours would look a lot better. Same shape you want as y, same shape. All we've done is shifted the graph up 3 units, okay? And critically, same shape, and we're looking for 7, 3, and 0, 10 as your coordinates. That's what we're looking for. When the change is on the outside of the bracket, so not inside with x, then it affects y, and it's a direct change, okay? If it's positive, you go up. If it's negative, you go down, okay? If it's multiplication, you double or you triple or whatever it might be, okay? Right, now for part B. For part B, the change is on the inside and it's a multiplication, not a, so we're no longer talking about a translation so we're not moving left or right. It is on the x-axis because it's on the inside, but we're not moving left and right. And you need to remember that when the changes to x, and we know that because the value is on the inside of the bracket, it's an inverse relationship. So we're not going to double, we're going to halve the x values. we're going to have the x value. So that 7 needs to get divided by 2, and 0 needs to get divided by 2. 0 divided by 2 has no effect, which means this point is not changing. What's going to change is that 0 needs to become a 3.5. 3.50. Why do I keep writing? Yeah, so 3.50. That's the idea there, and you'll just sketch. So you'll do your y, you'll do your x. We want to maintain more or less the same shape. Well, but this time you want to keep in mind that it is going to go up a bit faster because this is going to be happening at 3.5. So we're bringing everything is getting compressed is the idea. Everything's happening. So what's happening on the horizontal is twice as fast. That's what 2x is. So that will be 3.50. That's the change we're looking for. That the shape of the graph and the points will give you the correct points, and 0, 7, because 0 half of 0 is 0. Okay, no effect there. Okay, you can't divide by 0. That can't be done, but you can divide 0 by any number. It has no effect. You get 0. Okay, so that's what we're looking for there, and hopefully that's all right with you. There's going to be a lot of curve sketching, and critical is getting the shape right and the key points, the turning points, or where it cuts the axis. Those are the sort of points you need for curve sketching. Representing what algebra, the symbols look like graphically is a really important part of maths. We can see, we like to see what's happening. That's what it's about. Okay, so that's number 3. Number 4, GCSE again. I hope you would say functions, except for part A. Part A, it talks about the range, and we didn't really have to deal with that in GCSE. The key ideas, the key ideas we're going to be looking at A level is this idea of domain, and the domain represents your inputs. All the values that, and here the domain is stated as x is a set, part of the real numbers. That's what the R is. All the real numbers, the numbers that you can use in our number system for simplicity. We'll talk about that a bit more. Okay, your positive numbers, negative numbers, your decimals, everything that we're used to using. So your domain, that's your set of inputs, and you can put any number in here. Okay, there's no restrictions on the inputs. You can see for g of x there is a restriction. It's real numbers, but x can't be 1/5. Can you tell me why it can't be 1/5? Exactly. If we put a 1/5 in there, the denominator would evaluate to 0, and we cannot divide by 0. So that's why the restriction, the constraint that x cannot be 1/5 is put in for g of x. But for f of x, any value would work. Domain, your set of inputs. The range, which is what the question is asking for, that's your outputs. In other words, what we normally refer to as our y values. X goes in, you perform the function f of x, and then y is what the value that comes out. So we want to know all the values that y could be. And to help you with that, you got to look at, well, what's happening here? What's happening to the input? The input is being squared, then doubled, and whatever answer we get, we're going to take that away from 7. That's what f of x is doing. Okay? I'll say it again. See if you're with me. I take the input, I put in a number, I square it, then I double it, and that answer, whatever the answer is, I do 7, take away that value. What happens when you square a number? That's going to help you here. What happens when you square a number? Exactly. When you square a number, whether it was positive or negative, because we're dealing with all the real numbers, so it can be negative integers, negative decimals, it doesn't matter. But no matter what x is, if I set x is equal to minus 156.77, whatever it is, when I square that, this value will be positive. Will it always be positive? No. It can also be, what's the smallest? So in other words, what I'm asking now is x squared, what is the smallest number that x squared can be? X squared, the smallest number it can be, x squared has to be greater than or equal to 0. So no matter what input, the smallest value we'll always get for 2x squared is 0. This is kind of like the idea of completing the square and getting the minimum value. Hopefully you can make that link. X squared is always going to be greater than or equal to 0. The smallest number it's going to be is 0. Can you tell me what the range is? What can y be? Can y be any number? If I ask you what's the smallest y can be, or what's the biggest y can be, what do you say? And that helps you. I'm going to write the answer now and see if this makes sense. Y is always going to be less than or equal to 7. That's the range. Does that make sense to you? See what's happening here. The smallest, this 2x squared, the smallest it can be is 0. And if the 2x squared is 0, then y is going to be 7. We'll do 7, take away 0 is going to be the function, and we're going to get 7. But then after that, the only way for 2x squared is up. And as it starts to get bigger and bigger and bigger and bigger and bigger and bigger and bigger, y is going to be getting, so as 2x squared increases, y is going to be decreasing, yeah? The bigger the number I'm taking away, the smaller answer I get. So the only way for y is down, 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 into the negatives, into the negatives, into the negatives. The bigger x is, the smaller y is. The bigger the 2x squared, sorry, let me be careful. The bigger the 2x squared is, the smaller y would be. The biggest y can have, y is never going to cross 7. Because this 2x squared will never be less than 0. And the right way, I was using the term positive. The right term I should have used is it will always be non-negative, because 0 is not positive, 0 is not negative. It's non-negative, okay? And that's the answer. Hopefully that makes sense as this concept of range. All the possible values you can have as an output, and in this case, all the possible values have to be 7 or less. So we can use that inequality there. Now for B. You know, different ways you can do this. I'll give a clean screen for it. Different ways we can do this for B. And you could do it all in one go in the calculator. You can put it all in one go in the calculator. You just need to remember that what you're doing is you're putting the f function into the g function. So basically what we have is we're going to have 3 f of x, that numerator, whatever the f of x is going to be. And let me be more specific. 3f of 1.8. So you'll have to work, and you can put it all in one go. But 3f of 1.8, that's what we're going to have in the numerator. And then we're going to divide it by 5 lots of f of 1.8 again. That's what the x value is going to be, and from that we have to take away 1. So 5 lots of f. That's what we're looking for there. Yeah, is that what you did? If you did it right, the answer you should get is 0.975 or 39 on 40 is what you're looking at as an answer. Is that what you got? In terms of demonstrating the working, because you got to show process, you got to go a bit more detailed than this. You might want to do it separately. So for example, or you can put the whole thing. So you could actually in the calculator write 3, do the substitution. So 7 take away 2, 1.8 squared. Yeah, I'm substituting. X is 1.8. And then dividing by 5, 7 take away 2, 1.8 squared. We want 5 lots of f of x, and we're taking away 1. If you plug that in the calculator, this is what you're going to get, or should get, 0.975. Alternatively, you might want to work this out separately. So you just might want to work out this piece because you're using the value in the numerator and denominator. I can confirm I did it earlier that way. 0.52 is what you would get. And then so if you wanted, you don't have to show this. Again, you could put this whole thing in the calculator, or if you wanted to do it separately and then write 3 times 0.52 on 5 times 0.52, take away 1, that all of it is going to work fine. But you got to show some evidence of what the calculation is. What you cannot do is just pop it in, or should not do is pop it in the calculator and just put that answer. That's no good. Okay, show your method. There's something called method marks. We'll talk about marks as we progress, so you understand how to be best in the setup of the in the context of exams, to show the examiner you know what to do. Let's do with part C, and part C is interesting. Yeah, part C is what used to be 4-marker in GCSE. 4-marker in GCSE. Time for me to get a sip of coffee. Sorry about that. Actually, yeah, it's all good. It's all good. Right, so let's do this. How do we set this thing up? We set up our I'll write it in. I'll do this. So let f of x equal to y, or by. So, and sorry, g of x. What am I doing? G is what we're working on here, g of x, okay? So what do we have? I then can write that y is equal to 3x on 5x take away 1. And it's all about change the sign until we make x the subject. That's what we want. We want x, the input, to become the subject of the formula. And once we've done that process, we can change the letters. We'll talk about that change of the letters. It's always difficult to explain this, but it's easier to work with y than g of x, yeah? And g inverse x, what it is, the inverse is simply what function will, if I gave you the outputs, if I gave you the range, what function will give you the domain, would work backwards and give me the set of inputs. That's the idea there. So focusing on this, we got the unknown that we want to make x the subject. So we will multiply both sides by the denominator. So I'll get y 5x take away 1 is equal to 3x. Then we would expand. I'm going to go line and I'll continue here. We'll expand and we get 5xy take away y is equal to 3x. Then we will change signs so that all the terms with x are on the left. So I get 5xy take away 3x. That positive 3x becomes take away. And the negative y, it doesn't have x, so it goes on the right, is equal to y. Then we factorize. You recall this process? Yeah? We factorize and we would get x as a common factor. So we have 5y take away 3 is equal to y. And then finally, we want x by itself. That's why we factorize. So the whole expression we're multiplying x by goes on the other side. It's going to be y on 5y minus 3. That's what x is going to be. At that stage, we have what x is, but we got to change the notation that we're using because x represents the domain, the set of outputs. And so what we want to say now is g inverse. I'm just moving to the top. Follow with me. G inverse x, because we want to use x as the input. We want to keep with that notation of x being the input of the function. So g inverse x is going to be equal to, and where we see y, we replace it with x on 5x minus 3. So if we're now, because what we're saying now is where the inverse is that the outputs, the y values, what used to be the y values are now going to be the inputs. And if we put them in, sticking with the notation of x as the inputs, what we're really referring to the outputs because we're working backwards. That's what the inverse sign indicates. Hopefully that makes sense. That's what it's going to look like. We will take the input and divide it by 5x minus 3, and that will give us the what number we started with if we're working backwards in a function machine. So there you go. There you go. Let's go to number 5. Hope so far so good. And I haven't said enough in this video, but remember you can use the power to pause. Okay, you can use the power to pause. Number 5, first, actually, some fun equations here. Let's see what happens here. Okay, I'll get all the a's on one side. So I'm going to go 16a squared on root a is equal to 2. That will be my first move. And at that point, any point when you're saying, oh yeah, I see where to go now, you go. Okay, right. Or you can do your dance thinking, yeah, I did that. Then I'll switch everything to powers. So I'm going to say I actually have 16a squared on a to the power a half is equal to 2. That'll be my first line. We're doing number 1. Yeah, we're not focused on that one at the moment. And then I'll use the rules of indices. Yeah, simplify the power, and I'm going to get 16a to the power 3 on 2 is equal to 2. Yeah. Good so far. And I have that pause. Do you want to take it from here, finish the job if you haven't already? Then I'll divide by 16, both sides by 16. So I'll get a to the power 3 on 2 is 2 on 16, which I could just write as 1 on 8. Are we good there? We're good? We're good? Hopefully we're good. I'll just write that a to the power 3 on 2 is equal to 1/8. And then now I got to do the reverse of the powers. So this is telling me remember, this is square root. So the opposite of square rooting is squaring both sides. Yeah. So because what this is saying is the square root of a cubed is 1/8. That's what it's saying. The square root of a cubed is 1/8. That's one way of interpreting it. So I'm going to square both sides. and I'm going to do a to the power 3 is equal to 1 on 8 squared. So I'm getting rid of the square root. That's the denominator in the indices is square root. So I'm getting rid of that, and that is going to give me 1 on 64. So I now know a cubed is 1 on 64. In other words, some number multiplied by itself, some number written down 3 times. I write the same number down 3 times, and when I multiply it, I get 1 on 64. Well, the top number, so a is going to be the top number. You just need, in other words, what we're doing is we're going to cube root the 1 and cube root the 64. That's how you'll do this. Cube root of 1 is 1, and the cube root of 64 is, that's right, 4 times 4 times 4 will give you 64. The answer is a quarter. Final answer for this one, a quarter. So you haven't had to solve equations like this, but you have the skill set. Hopefully you can see, and hopefully you feel that, yeah, you had the skill set to do this because you have the experience working with powers and following the rules of indices. Okay, and that's what we needed there. That's what you needed here. Let's go to part 2. And the other bit, if you want more like these, just pop something in the chat. You know, yeah, I'm number 5. I think I want to practice more of those, and I can see what I can do for you there. Okay, so just pop in comments below. Yeah, pop in comments below, and we'll see what we can do there. For the next one, never seen one of these before. This is not GCSE territory, but hopefully maybe you had an idea. I'll give you an idea. Substitution. I'm going to say let y equal b squared. And if you didn't do that before, by me doing that, does that allow you to do the question now? Let y equal b squared. You see where I'm going with this? If y is b squared, then what we actually have is y squared plus 7y take away 18 is equal to 0. Would you agree with that? Yeah. Because b to the power 4 is b squared by b squared, which is y squared, as I've written it at the moment. So once we have that, then you could go for the formula, or you could look at it and just think, hey, I can factorize this. You can factorize this. This one is easy to solve at factorization. I get a y, because we're thinking 9 and 2. Yeah, and the signs have to be different to get that negative 18. So I'll go to plus 9 and y take away 2. That's equal to 0. And on the basis of this, we can now say that y is equal to negative 9 is one solution, and y is equal to 2. So those are your solutions for y. But you got to remind yourself, you're not solving for y. You were asked to find values for b, so we're not done. Now, we got to remember yourself, y is equal to b squared. But hang on, when you square a number, can you ever get a negative? No. So b squared not equal to minus 9. You got to write something to indicate that the minus 9 is not valid for the substitution. Okay, b squared not equal to minus 9. No solution. Or it's actually solution. Okay. It's actually probably better to write it like that. You know, somebody can give that commentary on that. But if we put b squared equals minus 9, no solution. Yeah, not possible. So now b squared is equal to 2. That's the one we're interested in. And what's the answer? If some number squared is 2, what's the number? Square root of 2? That's not good enough. That's not good enough as an answer. You got to have your 2 possible answers is plus or minus. So plus or minus root 2, an exact value we're looking for here. Plus or minus true. Can I just say that one thing here? I put no solution. I didn't comment on it, but they said using all real solutions. So actually, I should say no real solutions. In terms of real numbers, there's no solution to that minus 9. In terms of other type of, when we go into complex numbers and imaginary numbers, etc., we can get a solution for it, but that's not our purpose. So the domain we're dealing with, our inputs are real numbers, so we only concern ourselves with the real numbers. Okay, leaving it as an exact value here is best, although the question didn't actually specify that, but that's considered best practice. Okay, right. Whoa, what happened there? Lost my position. Whoa. Okay, yeah, that's good. Right, let's go. Number 6. Last bit, number 6. And what was showing there? That was another number? I don't know. Let me concentrate. Let's concentrate. For part A here, so part A, they said by eliminating y from the equations. So first thing, this is a substitution bit here. Hopefully you're okay with this. I'll call this equation 1, and I'll work in black. Let's keep it in black. That's our equation 1, and we have equation 2. And what I'll do is I'll sub equation 1 into 2. I'll just put in substituting equation 1 into equation 2. So wherever I see y, I'll write x minus 4. So 2x squared take away x being multiplied by x minus 4. That's your xy, and that is equal to 8. And then from there, what would we do? We would expand. We'll expand. So we get 2x squared minus x squared, and the minus got to be careful. There is a plus, so plus 4. And then I'll go ahead and do minus 8 take away 0. And I hope you're okay with that. What I've done there is, and actually what am I doing? I told you minus and a minus is a plus. What am I doing? I flagged up the signs and then I wrote the wrong thing. So it's plus. Yeah, it's plus. I did. No. Oh, actually, yeah, I'm confusing. This is where you have like one of those strange moments. Minus x squared. Yeah, you know what? Sorry, I understand what my mistake is. You were screaming at me with the mistake. I didn't hear you. Sorry, I wasn't paying attention. It's minus x multiplied. So that's actually going to be plus 4x. Yeah, plus 4x. Yeah, thank you. Minus x squared plus 4x. And then we're going to take away 8 equals 0. So that this positive 8 on the right became negative 8 on the left. So, because that's how we set up quadratics. Moves everything to the left is equal to 0. Simplifying here, the 2x squared take away x squared is going to give me x squared. So we get the x squared plus 4x take away 8 equals 0 as required. Tick. And that's the nice thing about show that. You know what the end result is. So even if I lost my concentration and I was doing the wrong thing here, I would realize I'm not getting the right answer, and that would help me to go back and check. So it's really nice when they do the show that questions, I think. Okay. Now, hence or otherwise, generally, if they told me to solve it like this, I'll solve it like this. And they want an exact answer, and you got to show all your steps. So no calculator. You can let the calculator help you in a direction, like know what the answer is, but use your algebra and get the answer. Okay. Right. So part B, I'll make space for part B, and I'll work from here. So we know that when we combine these two, we get x squared plus 4x take away 8. That's why they said hence or otherwise. We've done the elimination. In other words, we're going to solve that quadratic to find x. That's what you want to do. Find x using this expression, which is a combination of these two. And then when you have your x values, well, y is going to be x take away 4. Okay. So we got x squared plus 4x take away 8 equals 0. Now, if they've shown me this format, a plus or minus b root 3, that tells me that I'm not going to get an exact answer. That tells me I can't factorize. So there's two things you got here. You can either set up the quadratic formula. And when I say set up, it's not using the calculator to get the answer. You want to actually write the minus b plus or minus the square root of b squared minus 4ac on 2a and do your substitution for a is 1, b is plus 4, c is negative 8. You want to put that in and you want to work through. You can go down that pathway, show as your evidence, use the calculator to get your values, but show your evidence by doing the substitution. I'm not doing that because I want to show you something else and I want you to practice another skill. But you wouldn't get marks for that. Let's do complete in the square. You can use complete in the square and you'll get the answer just like this. So for the first piece, we know we would go with, well, what we would go with is x plus 2, half of the b value, x plus 2 squared. And thinking about it, that x plus 2 squared is going to give me plus 4 at the end of it, but I want a minus 8. So plus 4 has to be undone, and the way to do plus 4, what am I going to put on to get the minus 8? It has to be a minus 12. So that's my expression there, and hopefully we recall and we're comfortable with that strategy there for completing the square. But x plus 2 squared minus 12 would give me x squared plus 4x take away 8 equals 0. So we'll set the equals 0. Now we can solve it. So I'm going to put that 12 onto the right. So I'm going to get x plus 2 squared is equal to 12. And then I'm going to square root both sides, which means that x plus 2 is going to be equal to plus or minus the square root of 12. And I'm smiling now. I hope you're smiling now because, yeah, we can get x is equal to minus 2 plus 2 on the right becomes minus 2 plus or minus the square root of 12. And if we simplify, using our knowledge of surds, when we simplify, root 12 is the same thing as root 4, root 3, and root 4 is 2. So what we have, that root 12 is 2 root 3. Sorted. So what do we have? We have x is equal to minus 2 plus or minus 2 root 3. That's two different values for x. Now we can proceed to write our answers to the question. And I'll write them at the top here. Okay, I'll put them at the top here. So for the first bit, we're going to have x is equal to minus 2 plus 2 root 3. And then we need the corresponding y value, because remember we need that in these questions we need to find a y and the corresponding the x and then get the corresponding. We want to find values for x and y, the pairs of numbers. And y in this case, remember y is x take away 4. So I want minus 2 plus 2 root 3. The plus 2 root 3 will not be affected. It's the minus 2 take away 4, which will be minus 6. So that's a pair of answers there. And then your second pair of answers, well, I think you can finish it from there. I hope you're all right. I'm just going to make a bit of space there. Is that going to move the way I want it to? Just bear with me. Right, I just want to bring this down a little bit. That's good. Right. And my second answer, so that's answer 1. And the second pair of answers will be the x. So I'll just draw a line there. I want to just keep everything clear, you know. X is equal to, this side we'll go negative 2, take away 2 root 3. It's negative 2 and we're still taking away 4, so it doesn't change. The other pair of numbers will be y is negative 6, take away 2 root 3. So it's only the minus 2 root 3 and a plus 2 root 3 that comes into to form, okay? And that meets the brief, and I hope all of this makes sense. So use the power of video. You can look at it again if you would like to. Hope you found that useful and enjoyable for week 2, and look forward to going through some work with you for week 3. Take care of yourself for now. Bye-bye for now.